Gini Index is going to be discussed today. Hello friends. This is an attribute selection measure for decision trees. The algorithm for decision tree induction has been discussed in previous videos, and also the concepts of information gain, which is another attribute selection measure. So these two links I've given here. So it is a greedy algorithm, and the tree is constructed in a top-down manner. All the examples at the root, and then we go on dividing based on this attribute selection measure, okay, as in information gain, and now the Gini index. So this Gini D, how do we define it? So first we find Pi, which is the probability that an arbitrary tuple in D belongs to a class Ci. So Pi, probability that a tuple belongs to Ci. So this Gini D is defined in this manner: summation over all classes, product of Pi into 1 minus Pi, where we can further reduce it to this 1 minus summation over all classes Pi squared. So this is how we compute the Gini index of a partition D. Now, the higher values of Gini D or Gini index represent more disorder, meaning what? We want lower values. If an attribute is to be selected, then it should lead to lower values. So we first start by computing the Gini index for the partition D. Then we compute the Gini index using, say, attribute A to split D into the number of categories which are available in A, say V, and then we compute Gini AD. We do this for all features and choose the one with the lowest value. Purity of data partition has been discussed earlier, and this is the link to the video. So now we take an example. So this example, it has two features F1, F2, and it has 6 tuples. We can see that the two classes, the Y class and the N class, are equal in number. So P1 equal to P2 equal to 0.5. And this is the formula for reference. So Gini D is simply putting in the values of 0.5 for P1. So P1 squared and P2 squared, and we get the value of 0.5. So now we want to compute Gini AD, where A is the feature we are discussing, or the one we plan to split D. So how do we compute the Gini AD? We find out the different partitions Dj overall j equal to 1 to V. We find the Gini for each partition, and then take the weighted number of samples in Dj and total number of samples. So we go on doing this. So now to illustrate Gini AD, we are taking one feature now F1 of the same example set, and we find out D1, D2, D3 because F1 can take three categories 1, 2 and 3, value 1, value 2 and value 3. So D1 has two tuples, 1y, 1n. D2 also has two tuples, 1n and 1y, and similarly D3. So this again falls into the category of P1 equal to P2 equal to 0.5 if we are talking about D1. So Gini D1 is 1 minus P1 squared and P2 squared summed together. We get 0.5, and similarly it would be same for Gini D2, and this is, this is Gini D3 is also 0.5. So the overall Gini would be the weighted summation of all these, and we get it as 0.5. Each is 0.5 and the weight is same, 1 by 3, 1 by 3, 1 by 3. So we get 0.5. So for F1, we get the Gini as 0.5. Now let us look at F2. This is the second feature. It has only two categories, A and B. So D1, where F2 equal to A, has all the labels Y. Okay, so this is a pure partition. What about D2? It also has all tuples, but now with label N. So this is good actually. So what is Gini D1? See, the probability of class Y is 3 by 3, 1, and probability of class N is 0. So it is 1 minus 1 squared plus 0 squared, which is 0. So Gini D1 is 0. We can now understand that Gini D2 should also be 0 because this also is a pure partition. So for pure partitions, we are getting the Gini value as 0 because one of the classes has 0 probability, the other one has 1 probability. So the overall Gini also will be 0. So we have computed Gini F1D is 0.5, feature F1, and Gini F2D is 0. And we wanted lower Gini values, which means splitting on F2 is a better choice. So now we look at the two trees. One based with F1, splitting on F1. So we see that there are 3 branches and all of them contain a mix of yes and no tuples. So none of them is pure. What about F2? When we split on F2, we get both the leaves are pure leaves. There are all 3 tuples here with yes and 3 tuples here with no. So splitting on F2 is indeed a better choice, and this was also proved by the lower value of Gini F2. So purity of partition is more when we are splitting on the feature which gives us a lower Gini value. So I hope this is clear to you now, the use of Gini index for computing the goodness of an attribute to be chosen as a selection at the splitting measure. You want to split the decision tree at some point. You are at this point, you want to split. So which attribute to choose? This is decided by the information gain or now by Gini index. So thank you. Thanks for watching.